So first of all, I'm going to talk about history of atom, starting from Dalton and J.J. Thomson, and next to is Rutherford, and next is Bohr. So J.J. Thomson just discovered the electron, but he wasn't thinking about the orbit of atom. But after that, Rutherford was thinking about the electron's orbit, which is electron is moving around the positive current of it. But I'm going to focus on talking about Bohr because it's the most important thing, I think. So if I tell you about the Bohr model of atom, the energy, but he was focusing on the hydrogen. But he was most focused on the energy part. And he was telling about the energy, which is if I just shot a light of the energy of the hydrogen, and it's making like a color tape or something, color tape thing, and it shows that energy is like dielectric, and it was talking about the energy he was focusing on. And in the Bohr force, like Bohr part, there we can talk about the momentum, and there's like next there is periodically structure, which is about the periodic, like the structure should have a period, but as you know, everything is not the thing we expected. So we expect that every atoms, if it's combined together, we want this atom shape or structure to be periodic in state and periodically, but mostly it's not possible. So there's like three possible periodical structures. So one is crystallized, which is the ideal model of it, and the next is polycrystallized, and next is, I don't know how to say it in atmosphere. So the second one, the polycrystallized, is like the mix of atmosphere and the crystallized, which have a little bit of periodic structure, but it's not always having a periodical structure, but it's really different by the grain. I don't know how to say it, but grain is really different by the grain. So it's like grain is like if I try to explain about it, it's like a periodical thing. Like if the grain is really stable and if its grain is really stable and it stayed in a periodical thing, it's really close. It's getting close to the ideal model, as I said in the crystallized thing, and I can say in huddle, like running when we are running. So the crystallized model is like just running the track just without any obstacle, but polycrystallized is like if I just making a huddle, and there's several huddles exist, but if the huddle is not that much, it can be really close to just a simple track running. So the model you're trying to is to be trying to be grain to be really long, so there will be no obstacle that much. And next we talk about the cubic model, like the atmosphere, like cubic lattice, like there's different type, like shape of lattice, and there's like three shape. So one is like the simple cubic, just a cubic, really simple, and the next is body centered cubic, and the third one is like face center cubic. So the simple cubic is like on the each dot there's only atom exists, and if I try to explain what the body center body center cubic is like, there's on each dot there's a cubic. I mean, not cubic, atom. There's atom, but in the inside of it there's a one atom exists. So it's basically, that's why it's that body center cubic. And next is face center cubic, and it's same as the cubic, simple cubic, but on each dot there's like atom exists, but in each faces they're like in the center there's exist of the atom. So we're talking about just how much atom it can exist, and just like the area, like how much density it has, like that kind of thing we were talking about. And next we are talking about the diamond lattice. But when we are talking about the diamond lattice, we are talking about just a surface. But surface is really related with the normalized factor, which is, it can describe one vector surface. So anyway, if there's two vectors exist, we can make a surface. But to be simplified, it's really complicated to say in two vector, but we can simplify into one vector, as we know. So there's like, well, if there's like one surface, that just if I normalize that one certain vector of that surface, and that means that's telling the surfaces vector. So we usually, if I just say about a certain vector, we say about the directional vector. But especially in surface, as I said, we are talking about normalized vector about that surface, because it's much easier to tell just by one vector. So about talking about that, and there's some we can say in bracelet. There's like different bracelet, but we usually a surface normalized vector we say in like a round bracelet. And about the directional vector we are talking about in the square bracelet we are talking. And so we are talking about that, and just about in that surface, or in certain surface we can just cut it into it, and we are counting how much atom can be exist in that surface. We are just talking about a really simple thing. And next we are just having a review about the electronic potential. And if I said in the before, there's like Bohr atom model, and it has like in the center there's like positive source, and around it there's like a certain orbit. But especially we are talking about the hydrogen, and there's like a force going outside, which is called like a circular force. I'm not sure, but and there's like a force. We usually talking about the plus minus and in force, and it together, if I mix it together, it's like trying to get close. So there's like two force in the opposite side like this, and they are, if certain force is stronger than the other forces, will make the atom will be like getting smaller or getting the bigger, like because the force is, the electron is going to like go out or something. But as you know, the atom just exists like this, so that means each force amount is same. So we can make into like certain equation. And as we know, we were talking about the electronic like energy of potential, but when we're talking about energy or potential, we are also talking about, we can talk about the momentum, and also something in energy part, we can talk about the potential and kinetic energy, which is one, two, I don't know how to say the into fraction part, but like that. And we are talking at the end, we're, as I told you, energy was total of kinetic energy and potential energy. So we all mixed the momentum equation and potential equation and kinetic equation, and as a result, you're talking about the energy. So we all add into this one energy part. So if there is a certain equation it was telling. So this week was about this thing. So yeah.